Hi everyone, and welcome to the very first episode of Bad Dependencies. My name is Mackenzie Jackson, and I'm here joined by the research extraordinaire, Charlie Erickson. Charlie, how are you doing today?
I am currently surviving from whatever piece of human malware I have acquired myself.
Human malware. I love it. I love it.
Yes.
Yeah. We were like planning on doing this last week, but Charlie was literally like mostly dead.
Yeah.
But even in that mostly dead state, you did manage to pump out some research last week and get into stuff. So we're all pretty keen to hear about it.
Yeah.
What kind of started this is we've been finding an awful lot of malware, so much so that it's hard to do content on everything. Charlie, you're insane when it comes to pumping out content, but we thought this would be a nice way to let everyone know what's happening out there. So, Charlie, I'm going to throw it over to you to start with. What have you seen out there recently? Is there anything in the bad dependency world that's really caught your eye recently?
Yeah. So I think the big thing I've seen the last week and a little bit has been the use of images as a way of delivering payloads. Trying to hide them inside, and also just trying to stuff the bad code inside a bunch of noise. And I do have a couple of cases where that actually, when I sat down and took my notes this morning, I realized the two really big things actually came together in one piece of malware, which I was like, oh shit. I forgot there was actually one piece that had both of those. So the first one we've got is called NodeWave HTTP. And what you'll see is that it starts off by talking about sponsors for some reason. There's a repository here pointing to Git, pointing to the Axios repository. Axios is one of those big HTTP libraries that most people that have done JavaScript will probably run into. So that was the first thing.
So, but like when they do this and they put the sponsors up there and they link to these, I mean, this is just trying to give credibility, right? Like you look at this, I look at it, it's got a bunch of sponsors. It doesn't look that wow. Is that like the idea behind this?
Yeah, I think, and I forget exactly, but it's either the case that Axios actually has it like this, which I would find weird, or maybe what they're trying to do is try to put a bunch of noise up front in the README, so that you don't actually see the real README. One of the things that we will try to do is try to see, well, what is the implied package name based on the README? That's something we do actually see quite often, is that they will copy the README from a legitimate package and not change the name that's referenced. So you actually see a mismatch between the package name and what the README says.
If I go to NPM and I look at Axios, am I going to see, have they copied the Axios?
The rest of the README is definitely the Axios one.
Yeah, okay. Yeah. That's exactly, I'm just looking at it now. Yeah, they have all of the sponsors the same. So they're just, okay, so they're just trying to copy the Axios part. So right away, this looks dodgy now.
Yeah.
But what, let's go a little bit deeper. What actually, like, what's behind the scenes in this one?
Okay, so it's also worth noting the user that uploaded this. It's called Axios-WS-HTTP. And you'll see there's two packages. The other one is called Axios Fingerprint. We'll get back to that one later.
Okay.
Okay, so the first thing we go into in this case is the index.js. There's a little interesting thing that happens here, which is that it imports the file cancel Axios.js, and a couple of lines later, it calls a function called cancel. This is weird. I was like, okay, is this cancel culture gone too far? This is not what I would expect out of this package. So we'll have a look at the cancel directory first. And actually, some of these files are what you would expect from the Axios library. You'll notice also there's a thing here about capitalization that's a little bit off. Right? You have like cancel token.js where it's like camel case. Then you have cancel Axios, which is all lowercase. And then you have a mixed case below that. And then you have a JPEG called S.
Which is kind of a random thing to have in there. Like an image inside this type of folder is kind of weird, right?
Yeah, what's a picture doing in a HTTP client? So let's look at cancel Axios.js. Line number 4 it is opening up this JPEG, and then it's doing a bunch of math. And I'll spoil the fun. It's not about cancellation tokens or anything like that. What the actual cancel function does is, you can see it has like, while the offset for the JPEG file length, it +4, all this kind of thing, right? So it's trying to read into this JPEG file. And if we scroll a little bit longer down, so this is like 72 now, it has like Axios script is equals to hidden code. That's not right. And then it takes a UTF-16 buffer and it Base64 decodes it, and then it puts it into a PowerShell call. So, and then of course it calls it.
So inside this JPEG is basically just a bunch of nastiness. It's pulling it in. It's in Base64 as undecoding it and then running it. Is that right?
That is, well, yes, technically speaking, you're right. Let's look at it. This is JPEG. Not very interesting.
This is crazy. So on the screen here is that like the JPEG's an actual JPEG. It's not like a text file that you just like changed it to .jpeg, and in the text file there's like an actual JPEG here, which is a picture of a red eye, which is kind of appropriate, right? Like,
yeah, this is literally me copy pasting the JPEG with the malicious code into Google Slides. So, hey Google, sorry.
So this Google Slides has malware inside of it.
Yeah,
now.
it does. But yeah, the actual payload is inside of the metadata. So here's what happens if you call strings on it, which will basically just take any. I set the length to about 10, right? The minimum amount of ASCII characters in a row for it to actually print something. And what you'll see here is a little PowerShell script that goes and makes a HTTP request and saves it to the temp folder. And it's getting it from Discord, like the CDN for Discord. So somebody uploaded this file to Discord, and now they're downloading it and then running it.
So, I mean, this is kind of something that I've noticed a lot is threat actors using like endpoints like Discord or Google Drives or like even more recently like Google Calendars that we've talked about. So why do they do that and not just have it? Is it to avoid suspicion? Like, yeah,
it's a legitimate host name, right? That most sort of standard anti-malware kind of security systems will not flag on, right? Because it's used by so many different people. You can't assume that just because it's on this host that it's bad.
Yeah, right.
One of the things I've seen quite a bit lately actually is people just straight up hosting their malicious binaries on GitHub and downloading it from there.
Right.
Luckily, GitHub is pretty good about taking those down quickly when notified.
When notified, but there's nothing in there, like if you have a malicious binary and you upload it to GitHub, there's no automatic scanning or anything that happens in any of these tools, really.
No, unfortunately not. I mean, there are actual packages from NPM that if I download it, like just a tar file on my Windows machine, Windows Defender will go nuts. It's like, this is a malicious file. I can't even unpack it. Then you know it's really bad.
So yeah, okay. Well, let's get into that. Like for a minute there. Why not? And I get this question an awful lot, and I kind of have an answer to it, but it's not a really good answer. But why doesn't like NPM and that or like GitHub actually like why can't they identify some of these malware? Now, all right, maybe there's some there's some edge cases which we could understand if they didn't find them. The example of using like Unicode characters like before, maybe that's forgivable. But why can't, if Windows Defender can so easily find them, why not identify them? Is there a reason for it?
I think there's probably a couple of reasons, and this is pure speculation. One is pure cost. You have to run every single thing through something. It's a point of failure. Also, I think there's some laws around the world where if you admit that you become a moderator, it sets you up for a different set of criteria of standards that you are expected to follow, like free harbor kind of things. I would imagine I can also imagine too that like if you take on that responsibility,
So let's say NPM says we are now we're now scanning packages for malware, and one slips through. All of a sudden, it kind of becomes NPM's fault.
Yes.
And then you have this idea that, oh, that's really, I hadn't really thought about that, but it's so true. Like once you basically accept that responsibility, you've become that crunch point.
Yeah.
And why would anyone want to, especially NPM, as this isn't their core business, they're just a host of registries. Like,
Yes.
yeah, okay.
And obviously,
super interesting.
Antivirus is a huge attack surface, right? The amount of vulnerabilities historically that's been in the past in client-side, like virus protection type of stuff, it's significant.
The antivirus, I mean, like, yeah, isn't that the... Well, you know you got a virus when it's telling you to download some kind of antivirus to get rid of it. So, that's the classic example,
Of
right?
course. Here's the real plot twist. This file is not malicious.
What?
This is the legitimate, like, OSU installer.
Okay, but when you say that it's not malicious, it's still dodgy, as in the sense that couldn't you adjust the payload at the end? Like you look at this and you go, it's like, okay, it's not malicious.
Yeah.
That's because the payload's not malicious, which is kind of like usually, which is a lot the case with NPM packages, right? Where you have, you're getting a payload from somewhere and you want that payload, you want to be able to adjust that payload. That's the kind of part. So do you reckon this one's just kind of sitting and waiting?
Remember, there's another package from the same author.
Okay. All right. I'm getting ahead of myself.
Yeah. So in this case, the current version that's up there, as far as I can tell, it really can't do anything outright malicious. As is, it would have to be a different version because the Discord upload, you can't change in place. I don't know what it is. I've noticed a lot of references in malware to this OSU thing, which is like a dancing, like rhythm game kind of thing, from my understanding.
Okay.
I guess it's very popular in certain demographics. Second package. Again, you'll see this looks very familiar. It's this Axios fingerprint package. It's got the gold sponsors for Axios. It doesn't have that reference to the repository for some reason this time, which I found really curious. If we go to the index.js file, again, index.js usually is where you'll want to start if it's not package.json. And you'll see this file here is 540 lines of code. Curious.
Crikey.
There is like some fingerprinting salt and some sleep. And there's a function here called custom encoding stage 1 with some nice debug printing, some sleep. It's taking some sort of input. Like 540 lines of code, that's pretty significant. And this is, I think, one of the first packages, I think it's the first package I've seen where actually it looks like somebody had an LLM generate completely, like, it's not internally inconsistent code, but it just looks like it's doing things for the sake of looking busy. Like,
right, okay.
If we go to the next block here, you see there's like a function for process incoming data, and you see it's very verbose. It's got like a lot of like data proc, starting data processing pipeline, normalizing data. It's like something you'd expect out of a movie, like kind of on the screen, like all these lock statements kind of, and it's like enriching data, all kinds of weird stuff, and it's putting in random like sleep statements. Very weird. Now, if we go a little bit further down, by line 388, it starts to give the game away. So again, what we see here is a require statement. So it's importing the cancel Axios file from lib cancel Axios. And so that's a nice little function. And then below that, it has a anonymous function that is called right away. That basically all it does is sleep. It has a empty try statement with a catch block. I don't know why anybody would do that. Like, there's literally nothing happening here to try to catch. And I love some of these variable names. Like, there is a thing here called, it's a variable called obscure condition. And it tries to take the total memory of the system, and checks if it's more than X amount, right? So like it must be more than X amount of memory. Uptime must be more than X amount of seconds. And it will be like, if these are not met, these conditions, it will be like critical pre-flight check failed, system halt. And then here at the bottom, it calls this function that imports the cancel Axios file, which it's the same thing we saw earlier, basically.
Right. So that's what's kind of pulling in, getting that JPEG file, decomposing it, getting a payload from a Discord server or a Discord endpoint.
Yeah. And what is really curious about this is that if you actually look at all the other functions in this file, most of them are referenced, right? So it's not just functions that are there. All of them kind of are referenced, but the top level one. Right? So it's like all of this might look like it's not used if you actually were to like trace everything. But if you actually pulled at the very last step, it's like, yeah, this is not used for anything. It's literally just filler. Very interesting, because now you have to try to pick out like, okay, so what is this code trying to do really? And it's just there to fill out page space.
But so is that kind of what you're referring to, what like the LLM has generated, just a whole bunch of like just noise, and then you have a couple of lines of malicious code, but they basically go unnoticed. And also because in this case, it's just pulling in a different library. So there's not even anything really like suspicious going on other than it's pulling in a dodgy library. Like, that's right?
Yeah, so it's pulling in this file, right? So all of the same files that we saw from the previous packets are there. In this case, it is, right, the name was Axios fingerprint. And yes, there is something that looks like a fingerprinting thing, but there's nothing to do with Axios, right? It's not a feature of Axios.
Right.
They're just using the name for sort of believability, I suppose.
Right.
Now, if we look at the file that it's reading, right, the test file, stest file, the JPEG, you see a different URL. It is like called Incentive Forts Philadelphia Traveler, and then it's hosted by Cloudflare on the trycloudflare.com domain that they use for like free customers. Unfortunately, this doesn't resolve, but the file it was going to download was called Windows Host Handler. Not OSU anymore.
So this looks like a pretty targeted campaign towards Windows machines too, as well. Like before you mentioned like PowerShell scripts and everything. So this kind of looks very like Windows focused.
Yes. Yeah, this would not work on any other OS.
Is it often the case that it's OS kind of contingent, like that these systems are going for?
Yeah, so it really depends on the threat actor a lot of the time. Some of the ones that are simpler and are not necessarily as motivated kind of threat actors, if they are dropping secondary stages, it's usually pretty OS specific. What we see from some of the more nation state type of attackers, like the North Koreans that we've reported about in the past, some of the Russian threat actors, they will actually consider all the different OSs, and some of them will try to target and even execute within Windows subsystem for Linux. It's a Linux inside of Windows. They will handle those specifically. But
that, yeah, I guess that's coming from. To me, this doesn't scream nation state. To me, this screams kind of something else. Something else, almost like a proof of concept, almost in a way of like, okay, it's doing something dodgy. They haven't quite executed on it. There's a lot of just weird stuff going on.
Yeah,
and it's not like overly sophisticated.
No. Definitely not. They're getting there, right? I mean, they're definitely proving some of the delivery mechanisms and things like that, but they're not there yet.
Not there yet.
We're very thankful for, because we get to see all of them doing this stuff in real time, right? That was also the case with some of the things around the OS Info Checker ES6 package, right? We tracked them for like more than a month, seeing as they were kind of building up all the foundational things for how to deliver their payloads.
It's that super interesting kind of area where you know it's dodgy, but you're also just like very curious as to like where they end up going with it.
Yeah, I mean,
Which is for sure.
I see it sometimes, and I'm just like, I see packages where I can tell that they are putting down the foundations for doing something, right? Like, this makes no sense. I can't tell what it's doing that's malicious. Like, it's not there. It's like a Minority Report, whatever the movie is. Like, I can see there's about to be crime here, but I can't prove it. It's just smell.
What do you do when you find a malicious package? So like let's say in this in this case where there's actually kind of the end result, right? The end payload. Like in the case of the Cloudflare, it's not resolving. And in the case of like the like what we're talking about with Discord, the endpoint, it's not actually malicious.
Yeah.
What do you do in that? What do you do in that case? Do you still report this? Do you leave it? Like what happens?
Most things we don't report because, frankly, the reporting process takes such a long time, right? You have to provide all the evidence. With the amount of packages that we are going through, it's just not feasible. There are cases where we do report it where it's especially bad. So in recent memory, I have reported some of the ones where they are hosting malicious, like straight up malicious binaries on GitHub, for instance. I will report those. Also, when they are using C2 servers on hosts that I know are especially sensitive to it, like Hetzner, I know they are really sensitive, and they will come down on you pretty hard. Like the first time I got a mail from the Hetzner legal team, I was like, fuck, I don't want that, please. They take it very seriously. So I have reported like C2 servers to Hetzner, for instance. Just to fuck with these people.
All right. What else have we found out there in the ethos right now? We have another case that I see you have lined up here.
So the third case, it's a cute little one, and this is a package called express.js-session. So you see here, this is a very classic package that does like the two previous cases where it pretends to be related to Express.js, which is a HTTP library for hosting HTTP applications. So you see the GitHub repository is under the Express.js user account, and the actual repo name is called session. The actual Readme suggests that it is from Express.js. Now, it should probably not be a surprise because it's got 256 weekly downloads, just started. Oh yeah, and this is the user. I really want to figure out what the rest of the text in their profile picture says. What we can see is like, makes sense, the ample, we can, something, characters, can add is needed, we, something. I'm so curious. Like I tried reverse searching it, but couldn't find anything. Yeah. So again, index.js, where we often start. Again, this is a session library, supposedly. And on line 5, what it does is that it requires the config.json file in the config folder, which is interesting. Little known fact about JavaScript is that you can actually require files that are not JavaScript files.
Hang on. So you have a JavaScript application, you've got a Node application. You can require non-JavaScript, like dependencies almost.
Yeah, I mean,
how does that even work?
So in the case of JSON, right? JSON is technically a JavaScript thing, but with things like pictures and stuff like that, certainly in TypeScript, you can actually import pictures and stuff as a requirement. It always surprises me when I see it, but it's really cool when you do write code. It's like, why put in if I'm putting in an image tag, why would I want to specify the name of the file by just like a path when I can import it and my TypeScript checker can actually check like, yeah, this file exists. Cool little fact. So it's requiring this JSON file. Don't be freaked out. Yes, this works. You also see it has some functions for like computing metrics. I don't know why. And there's a session manager. Does nothing, really. So let's look at the JSON file. Oh no, first we go further down to the bottom. You'll see there's also a function called execute config logic. And what it does is that it takes the config file it required in, loads the path to an icon, it reads it, also adds a session into the session manager. It then looks for, and this is a regex for a base64 blob, right? It's A to C 09 plus / equal sign, minimum of 20 characters. If it finds that within the JPEG file, data file, it will then base64 decode it and call eval with it. So this is a very obvious case of like, yeah, this is executing something dodgy. Config file, that is just a path to a file called icons/icon.png. And it's not a PNG. Try to view the file, it does not load.
Right. So this feels like more like there's just text behind it.
Yeah, so the interesting thing is, technically speaking, there is a PNG in there from what I recall. Like, it's at the end of a legitimate image. But these guys have not made their thing both be a valid image and text. They just added it at the end.
Right.
Which breaks it.
Yeah. I mean, I guess, like, what's the point of having the image there in the first place? But I guess just makes it weirder.
Well,
this case, it makes it, like, weirder to look at.
Yeah, here's the thing, though, right? So if somebody was smart, they would, in their malware analysis pipeline, say, okay, let's find all images like PNG, JPEG, GIF in this package, and let's see, are they legitimate images? And it would catch this out in an instant.
Yeah.
So, disappointing. Don't know what this image is. Again, we run strings on it, and we see a base64 blob. So, decode that, and here's what we get. This is a very classic kind of payload that will take the username, the home directory, current working directory, and it will put that into a little payload, and then it will post it to a domain. This domain was registered on May 15th, 5 days old at this point. Clearly registered just for this purpose. And I think there's some Unicode characters in it, right? The xn --.
Oh, classic typo squash.
Classic. Yeah. And then it just sends this data as JSON.
And what is this ultimately doing? Is it trying to it's just trying to load in that malicious package? Or
no, it's actually just sending data. It's just sending this data, like the username, home directory, current working directory.
Yep.
There's a lot of effort for that.
Yeah, there doesn't seem to be anything like particularly spicy that it's capturing. Like, we're not looking like, usually when you see something like this, it's kind of like if they're going for low-hanging fruit, they're just going to try and get credentials, session tokens, or like some like crypto stuff. But here it's literally just kind of, I mean, not really information that you'd even kind of consider too sensitive. Or am I wrong in that?
Very standard what you'd see out of a security researcher, bug hunter kind of playbook in terms of the data they collect.
So this is probably a bug hunter trying to get a dependency confusion like conflict to get something out. Something along those lines?
It could be. Also, some of these attacks evolve over time, right? We've seen these kind of things with the OS info checker thing, right, where it didn't do anything malicious at first, and then they were slowly building out the full attack chain. So I think it can be premature to make assumptions about a lot of these things.
Yeah, I think that's kind of like the fact that it's loading in something dodgy should be enough to kind of raise the alarms, and then I guess all they need to do is change that image. Like, if it's already worked, it's already base64 encoded. You put something more malicious in there, it's not necessarily going to change much, right? Like, in terms of how it all looks and how it all functions.
Yeah, we also saw this obviously with our North Korean friends, right, where they were debugging things in real time, where actually, technically speaking, the package wasn't malicious in practice for quite a while, because it literally couldn't do anything because it was broken.
Yeah, because it was broken.
But the intent, right, what it's trying to hide is visible, to everybody, right? This is not normal code.
It is, yeah. And I guess that's the interesting thing about this too, and especially if you have a remote endpoint being called, then it's just so easy. Then you don't even need to release a new version, because when you release a new version, then it's going to presumably be checked by certain tools like ours. But if you just update, if it's missed and it's just calling an endpoint and that endpoint releases malware, then it's going to be bad. Well, I mean, like some really interesting case studies that we've seen out there. So kind of the latest and greatest trend on there, using images and other things to kind of load in malware. So the JPEG version and the PNG version. Would that work? Does that help at all? Do you think or is you might as well just put the put the code in there?
No, honestly, I mean, this is as old as time immemorial. I mean, you have seen malware do this for literally decades. There's nothing new in the putting things inside of images. I like the trying to basically generate so much noise and trying to stick it inside legitimate looking code that actually really does nothing. I thought that was really genius. But the problem is that every single time you try to hide things, you're generating signal for us.
Yeah.
One of the things about the Ripple attack that actually was good was that the actual footprint of it was really tiny.
Yeah.
Right? It's very surgical. Anytime you try to hide, you are generating signal. Even just something we've been experimenting with lately is looking at entropy of a file. And what you'll find is that the entropy of a file can actually be a fairly good indicator of if it's malicious. It's not 100%, but generally, the more it's trying to hide something, the higher the entropy will be. Also, if you see a mixed file where it is legitimate code, you remember all the cases where they will try to hide with a white space, so if it's not word wrapped.
Yeah.
What you'll see in the entropy graph is basically the entropy will dip down to almost 0, and then it will spike, right? Because a lot of white space, entropy eventually, approaches 0, and then you have these really random blobs. That sticks out like a sore thumb, because if you take a normal JavaScript file, it has certain patterns because of the structure that will land the entropy around a certain value. Once you divert from that, we can pick it out statistically.
That's really interesting. Identifying malware based on entropy. And for those, if you're not familiar with the term entropy, maybe even I'll get it wrong. Entropy is basically the amount of randomness that there is, or the amount of variance in it. So a high entropy string is like an API key or a unique identifier where there's just kind of lots and lots of random different characters, which that level of randomness. Is that how you would describe it too, Charlie? Like a level of randomness?
Yeah.
Super interesting. And that makes total sense. Often, these little indicators where we spend so much time trying to write rules to identify malware and malicious code, where using something like entropy wouldn't have come across my mind at all, because that is very, very interesting. And then as soon as you encode something in Base64, right, entropy is just going to spike like crazy, because that's literally what it is. It's high entropy strings now.
Yeah.
So
it certainly has a signature of its own, right?
Yeah.
And the second that you are encoding things in Base64, that is something that provides a piece of signal for us, right? It allows us to describe the code, and one of the things we do look for is these big blobs, right? What is this blob? And the more we can try to define it, the more precise we can be in this is something that could be potentially not expected or something that is not desirable.
Well, look, we've gone a little bit over time today, but I think this has been a great first episode. We're going to be coming at you fortnightly, or roughly every 2 weeks. We're going to be sharing with you the latest and greatest of what we're finding in the world of malware. Charlie's going to be giving us his technical analysis of it, and I'm just going to be here asking the dumb questions that the audiences can't ask. So there we are. But Charlie, thanks for being here. I look forward to the next week, and thanks everyone to listening. And until next time, That is it for Bad Dependencies.
Thanks, Mackenzie.